All right, this is lesson 2 of chapter 13. If you haven't gotten that out of the content library yet, I've uploaded lessons 2, 3, and 4 already there, so you can copy those over to your own notes if you're using them. So today we're talking about solution concentration, and in the lab when we use a solution, many times you'll see stock bottles of solutions sitting around the lab. Those are of specific concentrations, which means it's a specific value of the product in that volume, or in that bottle. It's in a volume that's diluted with water. And so we have lots of different chemicals that we use that come in different concentrations. So it's the measurement of that concentration that we're really interested in. So we're going to describe concentration using different units today. We're also going to look at how concentrations of solutions are determined. And then we're going to talk about the most common one used in chemistry, which is molarity. So some new vocabulary: concentration, molarity, a word that sounds similar to molarity, molality. And we'll also talk about percent by mass and volume. So those are all the different concentration units we're going to be looking at. Remember, in a mixture, you have the solvent. And the solvent will have a solute, and together, these things together make the solution. What we're interested in a concentration is how much of the solute is in the solvent. And so we would say sometimes if there's a whole bunch in there, we would say that that is a concentrated solution. Or if there's not very much in there, you would have a dilute solution. So a good example here is tea. This is one with tea in there that's seeping, and we'd say that this one is dilute and this one is more concentrated. I always think about a glass filled with ice, and when you have ice in there and the ice begins to melt, your drink becomes diluted because you have more water in there. So the concentration of a solution is the measure of how much solute is dissolved. Now this lesson has a form or a worksheet that goes with it that you've been assigned, and I'm going to do some practice problems and then turn you loose to do those problems. So just hang with me and you'll see how this works. When we express concentration, some of these you're pretty familiar with, and we're going to hit each one of these as we go. And again, concentration in the lab is super important because we can take these stock solutions that we buy through our chemical supply companies or even at the grocery store, and we can take those and we can dilute them and change their concentrations and things like that. So here we go. We're going to jump into this real quick. The first one we're going to look at is percent by mass. This one is pretty common in the grocery store. We see these as an expression of concentration in everyday life. For example, the hydrogen peroxide you buy from the store is 3% hydrogen peroxide. That means for every 100 grams of the solution, 3 grams of it is the H2O2 or hydrogen peroxide. The other 97 grams of it is water. Percent by mass, so let's say percent mass, is equal to the solute over solution times 100 by mass. So the grams of solute over the grams of solution times 100. So this one's just a percent equation. And again, it's pretty common. We use this for hydrogen peroxide and lots of other things that you see. So here's one that we can do together. This says in order to maintain a sodium chloride concentration similar to ocean water, an aquarium must contain 3.6 grams of sodium chloride per 100 grams of water. So what's the percent by mass of sodium chloride solution? Well, that would be 3.6 grams over 103.6 grams of solution, because it's the NaCl plus the water times 100. And so that's going to give us our percent. When we calculate through that, that gives us a 3.47% by mass concentration of salt water for the aquarium. So that's a sample of that type of a problem. If you go to your worksheet that was assigned with this lesson, you guys can go ahead and do numbers 1 and 2 on the worksheet. So pause the video now and go and practice on your own. All right, so another common concentration that we use in everyday life and sometimes in the lab as well is a percent by volume. A percent by volume is used typically when you have liquid solutes. So when we're mixing two liquids together, then we'll do a percent by volume. Alcohol that we use both in alcoholic drinks and in the alcohol that we use in the maybe in the bathroom that we call rubbing alcohol or isopropyl alcohol. They're given in percent by volume rather than percent by mass. So a percent by volume is just exactly what it sounds like. It's the volume of the solute over the volume of the solution times 100. For example, a liquor with a 40% alcohol content means that out of every 100 milliliters of solution, 40 milliliters of it is alcohol and the other 60 is water. So these are calculated the exact same way. So I'm not going to solve through one of those. Again, it is the percent volume, and the volume can be in any unit as long as the units are same. And so the solute volume, so we'll say milliliters or liters over the solution volume. It can be milliliters or liters. They just have to line up. So whatever one unit is, the other one's got to be in. So go ahead and pause the video, and you guys can do numbers 3 and 4 on the worksheet. Okay, so the most common one that we use in chemistry, and I would say we're going to use this 90 plus, if not more than 90% of the time. This is the concentration unit or concentration expression that is almost exclusively used in laboratory chemistry. And this is a concept called molarity. And basically this is moles of the solute over total volume, which we usually use liters of solution. We're going to say this equals molarity, which is symbolized by big M. So if you were to get a stock bottle of a chemical in the lab, you might have like HCl, and it would be 12.1 M HCl. So this 12.1, this M is molar, which means there's 12.1 moles per 1 liter of solution. So if I were to pour out a liter of that, I would have 12.1 moles of HCl in that volume. So that's what molarity means. So molarity is super common. It's the one that we're most interested in because we're able to dissolve something in water. And so this is the one that we'll use most often with solid solutes. So let's try one here. All right, in order to do this, you're gonna need a periodic table because we're dealing with a mass of glucose, and our molarity equation is moles of solute over liters of solution. So we're gonna have to take our 5.10 grams of glucose, and we're going to have to convert that into moles first. It's going to be 180.18 grams of glucose for 1 mole of glucose. All right, so 5.10 divided by 180.18 is going to equal 0.0283 moles. So molarity is equal to 0.0283 moles divided by, and this is going to be in 100.5 mLs. But we're going to have to divide that by 1,000 to get 0.1005 liters, because it has to be in liters. So 0.0283 divided by 0.1005, and that's going to give us a molarity of 0.282 moles per liter. So we would say that this is a 0.282 molar solution. And after solving that, I just noticed they gave us the molar mass there of 180.16 they found instead of 180.18. I'm pretty sure either one's going to give you a pretty similar answer. So that's how that guy's solved. If it went too fast, then back the video up and watch that guy again. But now you can do numbers 5 through 9. In 5 through 9, you're going to go a couple different directions. You're going to solve for molarity, but then you're also going to be given molarity and have to solve for some other factors as well. All right. So the next calculation we're going to do is that of a dilution. A dilution is where we're going to take a concentrated or a highly concentrated solution and we're going to dilute it. We're going to add water to get it to a lower concentration. So the dilution equation is M1V1 equals M2V2. And so this is just a plug and chug kind of equation. So basically we're just going to say the molarity, the moles, is going to be equal in a dilution. So if I have a more concentrated solution and I pour out a small amount of this into a new container and then fill it up with water to a given value, the amount of moles I removed from this and the amount of moles I added to that are equal. So when we take molarity times volume, so if I say molarity is moles over volume, if I rearrange this equation and I say molarity times volume equals moles, well, if the number of moles are the same between condition 1 and condition 2, if these are the same value, then any two things that are equal to the same thing are also equal to each other. So then we get M1V1 equals M2V2. And I'll give you a dilution sample problem here. Hopefully that'll help you. It says if you know the concentration and the volume of a solution you want to prepare, you can calculate the volume of stock solution you'll need. And so what volume in milliliters of a 2.00 molar calcium chloride stock solution, so what volume would we use to make 0.300 molar solution that has a volume of 0.50 liters. So basically I'm taking these two together and setting these as V2 and M2, and then this guy here is M1, and then it says what volume, and so that's V1. So these two go together here and these two go together here. And so you can see in the equation that I've written here. So we're going to solve 0.5 times 0.3. So we get 2.00 V1 equals 0.15. We divide by 2, so V1 equals 0.075 milliliters. So I would need 0.075 milliliters of my stock solution, which means I would take 0.075 milliliters of my 2.00 molar and add it here and then fill it up to 0.50 liters with water. And that would give me my new solution. The new concentration here would be 0.300 molar. All right, so that's how a dilution works. And so basically I'm just taking a sample of a more concentrated solution and I'm adding water to dilute it to make it less concentrated. And so if you read this problem carefully and you see the math, hopefully you can work through that. If you guys go to your worksheet, you can go ahead and do numbers 10 and 11. All right, the last concept we're going to use, or we're going to look at, is one that we're going to use only when we're talking about solution chemistry, and this is a concept called molality. Molality is similar to molarity in that we're dealing with the moles of solute, but instead of it being per liter of solution, we're looking at it per kilogram of solvent. So this is the only one that where the denominator is dealing with the solvent rather than the solution. And so we're going to say this is kind of italicized M, and we call that molality. And so this concept is helpful when calculating the effect a solute has on the physical properties of a solvent. So if you were ever made homemade ice cream in an ice cream maker, you probably put salt in ice to get the ice to be very, very cold. That salt is the solute. The mass of the ice is we're going to say the kilogram of the solvent, and we can actually calculate how cold that ice will get with salt in it. And water will get very, very cold, way below freezing if you add a solute to it. So that's essentially what we will be doing. That's going to be lesson 4, I believe. But in the meantime, we need to learn how to calculate molality. And so molality is calculated in a very similar way as molarity. But basically, we're going to say we have 4.5 grams of NaCl. And we're going to calculate the moles of NaCl. So I need the grams of NaCl from the periodic table is going to be equal to 1 mole of NaCl. All right, and that's 58.43 grams, which gives me 0.0770 moles of NaCl. And so to calculate the molarity, or the molality, I need 0.0770 moles of NaCl over the kilograms of H2O, which is the solvent. Now this says 100 grams of water. So if it's 100 grams of water, I have to take 100.0 grams and divide it by 1,000 to equal kilograms, which gives me 0.1000. And when I do that, the molality is equal to 0.770 molal, which is this italicized M. All right, so hopefully you've seen how to calculate that guy. Again, you can rewind the video and watch it again. Now you can do the last problem on the worksheet. If you are struggling with any of these concepts, you can get on the book through My Sarasota on the my.sarasotacountyschools.net website. You can go to Connected, which is your textbook site. Click on the Florida Chemistry. It's chapter 13, lesson 2. You can read through. It's got a lot of good pictures there and some sample problems. And then also I have office hours tomorrow. The office hours will be at 10 a.m. So feel free to jump on and ask any questions about any of these that you didn't get. So you can now do the last problem on the worksheet. Good luck. And if you have any problems, let me know.